Hi there, folks. Today we're looking at inscribed angles, and we're talking about inscribed angles within a circle. An inscribed angle is basically an angle that all 3 points of the angle are on the circle itself. The vertex is on the circle itself, and then the 2 rays that form the angle also intersect the circle at different locations. Okay, so an inscribed angle is an angle whose vertex is on the circle and whose sides are chords. All right, and that's the idea here. A chord, remember, just intersects the circle at 2 different spots. Thinking about that segment. Okay, so when you think about an inscribed circle, an inscribed angle, all 3 points of the angle are essentially on the circle itself. Okay. The intercepted arc is the arc formed by the intersection of an inscribed angle and the circle. And, we've already kind of talked about that from the perspective of a central angle. A central angle kind of creates an arc when it hits this thing. Well, an inscribed angle does the same thing. Okay, so when we talk about that intercepted arc, it's where that angle kind of hits the circle. It's the arc that's created from that angle. All right. The theorem that we have in regards to these inscribed angles in the intersected arc, the relationship that exists here is the measure of an inscribed angle is always half the measure of the intercepted arc. Or you could even think of it the other way. You could say that the measure of the arc is twice the measurement of the inscribed angle. Okay, so you can kind of think about it both ways. We tend to state it this way. So we state it this way, that the inscribed angle is half of the measurement of the arc, or we could say that the measurement of arc is twice the inscribed angle. Okay, take the inscribed angle times 2 to get the arc, or take the arc divided by 2 to get the angle. Okay. For example, if I look at something like this guy, it says find the value of A and B. And so as we kind of look around this thing, the first thing we notice here is that A is this kind of section right here. It's this arc from P to T. And we notice that that's associated with this angle right here, this 60-degree angle. And so that 60-degree angle, that is an inscribed angle. And so if the arc is twice the angle, or the angle is half the measurement of the arc, it means that A has to be a 120. And so again, when we look at that, the arc is 120, so the angle is half the measurement of the arc is twice the measurement of the angle. That's the relationship that exists here. And now from here, if we look at B is talking about this angle down here, if I kind of highlight this. So angle B is talking about this inscribed angle, angle PRS, or angle SRP. And when we look at that, that kind of is associated with this entire arc, this arc that goes from P to S, or S to P here. And so when we think about the measurement of that entire arc, well, we already identified the A is 120. So that entire arc is 150. So if the measurement of the arc is 150, it means the measurement of the inscribed angle has to be half of that, which is 75. So that's our value for B. Okay? And so again, it's that idea of going back and forth. If the angle is half the measurement of the arc, well, the arc is twice the angle. Okay? Two inscribed angles that intersect the same arc are going to be congruent, and that should be fairly obvious to us, all right? If the arc that they're intersecting is the same, well, then the angles have to be the same as well, okay? They're half of the same arc, well, then, yeah, their measurements are going to be the same. An angle inscribed in a semicircle is a right angle. And again, when you think about a semicircle, when you think about the arc that's formed here, the arc measurement is going to be 180 degrees for a semicircle. So yes, the inscribed angle will be half that. It'll be 90 degrees. Okay. This last one, opposite angles of an inscribed quadrilateral are supplementary. That one's a little bit tougher to kind of wrap your brain around, but think about it this way. If I were to draw a circle with a quadrilateral inside of it, okay, so an inscribed quadrilateral, and it doesn't matter what kind of quadrilateral that is. When you look at these opposite angles, because it's an inscribed quadrilateral, this won't always be true for all quadrilaterals, but when it's an inscribed quadrilateral, this angle and this angle right here have to be supplementary. And the reason for that is if you kind of think about the intercepted arcs, like that first one, would have an intercepted arc of this portion of the circle. And that's not necessarily half the circle. We can't say for sure that that's 180 degrees. That might be 200 degrees, okay? But then the other angle is kind of focusing in on this portion, okay? And so just to kind of give you an example, if this guy is 200 degrees, well, then this arc over here would have to be 160 degrees, okay? Because they have to have a total of 360 degrees. But now think about the inscribed angles. The inscribed angles will be half of each of those. In other words, this one's going to be 100 degrees. This other one is going to be 80 degrees. And of course, those are going to add up to 180, because when you think about it, the whole way around the circle is 360. And if those two angles come together to equate to the entire way around the circle, well, those inscribed angles are going to be half the measurement of the entire way around the circle, which is 180 degrees. And that's why they will always be supplementary when we look at those opposite angles, okay? Because those opposite angles of the quadrilateral, well, those two inscribed angles account for the arcs that go the whole way around the circle, 360 degrees. So half of those measurements, the inscribed angles are half the measurement, are going to equate to 180 degrees worth of angle measurements, okay? For example, if I look at these guys, it says find the value of x. And so as I kind of look at this thing, just kind of piecing all of these things together, when you look at angle x, well, let's talk about the arc that kind of completes this thing. So right here, from here to here is 70 degrees. So from here to here, well, if you kind of think about this guy, this is a central angle of 180 degrees. So that means the whole way from here to here also has to be 180 degrees, okay? So the missing piece right here, well, that's got to be 110 degrees, okay? And that kind of goes back to that idea that central angles are congruent to the arc, or we could just look at it and say, hey, it's a semicircle, that's 180 degrees for this guy. Well, then from here, we could say, well, angle x now. So right here, angle x, the intercepted arc is this guy. Well, x has to be half of that measurement. So this is going to be half of that measurement, so that's going to be 55 degrees. Okay? We could approach that in all kinds of different ways, and we could approach that from some different perspectives. That's probably the easiest way to approach that one. Okay? If we look at the next one here, once again, as we kind of work our way around this thing, we notice that this guy right here is 70 degrees. Okay, but that's associated with, in terms of an inscribed angle, we don't really have one that's associated with that. You know, I could maybe draw this guy and say, oh, that's the inscribed angle that's associated with that. The only inscribed angles that we have here would be this guy right here, and maybe this guy right here. And what you should notice right away, that's 70 degrees. That's a misdirect. Okay, when you look at these two angles that I've just drawn, the one in red that marks the x and the one in purple that marks the 38 degrees, they have the same intersected arc. They're both talking about this arc right here. Both of those angles give you this same arc. And so what's true then is that those two angles, because they're both inscribed angles, have to be the same. So without doing really any work here at all, sorry I didn't label this previous one, 55, without doing any work at all, I can immediately say that x equals 38 degrees. Because I have an inscribed angle that gives me the same arc, well, then that has to be 38 degrees as well. And you could work through this, even if you don't remember that theorem, you could look at it this way in 2 steps and say, okay, well, if the angle here, the inscribed angle is 38 degrees, well, then the arc over here, well, that's got to be 76 degrees, okay? And now kind of working backwards, if that arc is 76 degrees, this inscribed angle that gives me that arc would have to be half of that, which is 38 degrees, okay? But again, we can kind of cut that step out because we can see 2 inscribed angles that give me the same arc. Well, those 2 angles must be the same, okay? If I look at the last one here, this one, I have an inscribed quadrilateral. And so the idea here is this. If we kind of look at this guy, so right now I have these 2 angle measurements of the 60 and the 180. In other words, this entire arc right here, kind of trace that guy, that entire arc measurement is going to be 140 degrees. Okay? So if that entire arc measurement is 140 degrees, well, then that means the inscribed angle that gives me that arc right here, that inscribed angle that gives me that arc is going to have to be 70 degrees. It's half that measurement. And now from here, these two guys, these opposite angles, well, they have to be supplementary, which means x has to be 110 degrees. Okay? And that's using the theorem that was stated, saying, hey, those opposite angles have to be supplementary because they help us form the entire circle, and they're half the measurement of that circle, 180. Okay? You could also look at it this way. Instead of drawing that, I could say, hey, the arc that I have drawn so far is 140 degrees. Well, let's think about the rest of this arc. Okay, so this arc right here, so if that's 140 degrees, sorry, that was terribly drawn. Oh, I got a little out of control there. Now I erased the whole thing. Okay, so that's 140 degrees for the green piece. That means the purple piece that I have drawn now, well, that's got to get me all the way to the 360 degrees. So that's going to be 210. Or sorry, 220. Okay, so to get me 360, that's going to be 220. Well, now angle X, that has to be half the measurement of the intercepted arc. And so when you look at this, here's the inscribed angle. So we want to be half of this arc, which is 110. Okay, and so there's multiple ways we can approach this. Those theorems, most of the theorems that we just stated there, those corollaries, sorry, that we don't really need any of those. As long as we understand the relationship between inscribed angles and central angles and arcs and that kind of stuff, and use a little bit of arc addition, we can find these with a couple extra steps. Okay? This one, the measure of an angle formed by a tangent line and a chord is half the measure of the intercepted arc. Really, it's the same thing that we had with an inscribed angle, but now we're talking about this angle that's formed by a tangent line and a chord. Okay? And we talk about the intercepted arc. If you think about this guy like an alligator, it's the arc that's inside of here. It's the arc that this thing is eating that's inside the alligator's mouth here. Okay? And so when you look at that, we're talking about this guy right here. Okay? So if we're looking at the measurement of that red angle versus the measurement of that purple arc, it's the same relationship that we had for an inscribed angle, okay? The angle measurement is half the measurement of the arc. Now, granted, there's another angle that I could look at here. I could look at this angle instead. And if I looked at this angle, BDA, so it's another angle that's formed by the tangent line and a chord. Okay? And if I looked at that angle, now the arc that's inside of that angle would be this arc right here. And once again, the relationship is the same as an inscribed angle. Okay? That angle in red is half the measurement of the arc that's inside of it. Okay? And so when we talk about the intercepted arc, it's the arc that's inside of that thing that's created by that angle. Okay? For example, if I look at this guy, it says that if AD is tangent to the circle, find the measurement of CDA. And so when I look at this thing, there are two ways that I can approach this. So I want CDA. The first option is I could just ignore CDA and I could look at this and say, hey, let's look at this angle right here, this angle in purple. Well, if I look, the arc that's inside of that angle is 210 degrees. Okay, which means the purple angle has to be half that measurement, which is 106 degrees. So this guy right here has to be 106 degrees. If I could write, 106 looks like this. There we go. Well, now think about it in terms of a linear pair. When I look at this, let me erase the rest of this stuff. Right here, these two angles together form a tangent line. They form a line, they form a linear pair. So if that one's 106, these have to be supplementary. This guy right here has to be 74 degrees. Oh my goodness. Okay? Because they have to be supplementary because they form a linear pair. Okay? So the measure of CDA, 74 degrees. The other option here is we could start by saying, well, this isn't the angle I want. I don't want this 210. What I want to talk about is this guy right here. I want to talk about the arc that's inside the angle I want. See, this is the angle I want. Let's talk about the arc that's inside that angle. And so if I think about this for a moment, if this first guy over here is 212 degrees, well, the whole way around the circle is going to have to be 360 degrees. So I could do it like this and subtract and say, hey, this guy has to be 148 degrees. And now the angle that I'm talking about, CDA, sorry, I should have used a different color here. Let's recolor this in purple. Okay, that angle has to be half of the measurement of the arc that's inside of it. And so if that's 148 degrees, well, half of that is 74 degrees. Okay, and so there's two ways to approach it. You can either work your way around in terms of the arcs and then go to the angles, or immediately go to the angles and then find the relationship between the angles. Okay, so again, the measurement here of CDA, 74 degrees. Okay. And so kind of just to summarize this a little bit, inscribed angles are always half the measurement of the arc, or we could say the arc is twice the measurement of the inscribed angle. Likewise, when we have a tangent line and a chord, it's the same relationship, except now we're kind of talking about the arc that's inside of that angle. Okay, so the angle is half the measurement of the arc still, but it's a little bit more difficult to identify which arc we're talking about and the angle that goes with that arc. Okay.